When we are looking for multivalent metals, we ask ourselves the same questions we do for simple ionic metals, but we have to add one more question. So when I look at this species, let me get some color here. When I look at this, I notice that lead is a metal and that carbon and oxygen are non-metals. But I also recognize that carbon and oxygen are polyatomic. I don't have to do anything with that right now because my question was just metal with a non-metal, and the answer is yes. So I look at the metal. And my next question, whenever I have a metal, is this is this a regular group 1 and 2 metal that only has one valence electron, the charge is the group number, or is this one of them ones that's in the middle that might be multivalent? And lead is smack dab in the middle of your periodic table, right near the bottom. And what I have to do is go, okay, transition metal, that must have possibility for multiple charges or multiple valences. And a couple ways to look at it, you could look at your oxidation states on your periodic table, or you could look on your folded over chart. But what you're going to find out is lead could be 2 plus, or lead could be 4 plus. Automatically, that means that when I write the name, it's going to be lead. Because we already know that it's lead, and metals always keep their name, so it's going to be lead. It's going to be lead some charge. I don't know what charge yet. It's going to be 2 or 4 in Roman numerals. I'll come back to that in a second. The second part is going to either be a non-metal that goes to IDE, or in this case it's going to be a polyatomic, which I look up. CO3 I find is called carbonate by looking it up on the polyatomic ions chart. And on that same chart it tells me that each carbonate is 2 minus. I have 2 groups of CO3, so I have 2 carbonates, which means my total charge is going to be 4 minus. In order for this compound to be a compound, I have to balance out those 4 negative charges over here with the lead, and since there is only one lead, it must have 4 positive charges. Now if I do everything right, I should be able to come down here and see that what I figured it would be is a possible charge. It is. So this is lead 4 carbonate. The next one I see is tin and oxygen, so it's a metal with a non-metal. Tin is not one of those ones like lithium and sodium, potassium, ones that I'm used to. So I look for it, I find it, it's a transition metal, and I look tin up, and tin also can be 2 plus or 4 plus. If I check my oxidation states, I'll see that. If I check on the folded over sheet, I'm going to see that. So I know it's tin, and I know it's tin 2 or tin 4, but I don't know what it is yet. So look over here, and this is just O. And in that case, oxygen changes its ending to oxide, so it's tin something oxide. Oxygen is only ever 2 minus. Well, if there's 1 2 minus, this has to balance it, so it must be a 2 plus because there's only one of them. So this has to be tin 2. Tin 2 oxide. So all this means, the 2 just means it's tin with a 2 plus charge, not tin with a 4 plus charge. If it was tin with a 4 plus charge, it would be tin. Oh, and since O is only 2 minus, I would need 2. 2 oxygens would be tin 4. It's not, so I'm going to erase that, but that's just how, what's the difference? SNO2 versus SNO, and so if we were to use the wrong one, we'd have twice as much oxygen as what we were expecting. Last example, we have iron. Iron is very common multivalent that you'll see. So iron, looking it up, can be 2 plus, lots of 2 pluses, or 3 plus in this case. So iron, and again, I don't know, I just found out that it's multivalent, so I know I need brackets. Iron 2 or 3, I'm not sure what yet. This again, I see that there's 2 nonmetals here, one especially with oxygen there, it's a polyatomic. This is called hydroxide, I just looked that up on my polyatomic ions chart. Hydroxide. And I see on my polyatomic ions chart that each hydroxide is 1 minus. I have 2 OHs, each one is 1 minus, so I have a total of 2 minus charge over here, and only 1 iron, so I would be iron 2 plus. So this is iron 2 hydroxide. Iron 2 hydroxide. So with iron 3 hydroxide, what that means is I would have an iron 3 plus, balancing out with an OH 1 minus. I would need 3 of those OHs, and so I would end up with FeOH3. That would be iron 3 hydroxide. And you can see that FeOH2 and FeOH3, different compounds, need different names. That's why we always have to put in our Roman numeral. I'm just going to erase this because it's not on here. And that's how you would go from a formula to a name.